Hello, and welcome to another exciting episode of Cooking with Unity. I'm your host, Maximilian Moreau. With me is Jeffrey Hawthorne. And there's his hand and everything. So, nice of you guys to join us tonight. Phil, unfortunately, is not here today. I know that we've had a low fill rate lately, if you will forgive the pun. And actually, we've had a low fill and max rate. Max fill rate, yeah. Our max fill rate is bad, too. So, okay, I'm done with that. Sorry.
See if you can get my name in there somehow.
Jeffrey. We'll figure something out. We'll figure something
30
out.
30 minutes
that.
later. Okay,
Yeah.
let's start working with planets.
All right. Well, let's prevent that from happening by switching into main screen right now and doing it. Oh, wait, I didn't open the project, did I? Dang it. Knew there was something I forgot. Oh wow, that font, that takes a while. I wonder what Unity has to do for fonts. They probably has to render out textures of them and stuff. That's probably what it's doing there. All right, so here's our project. Let's see what we had. So we were working on our solar system test, and we have a script that creates a procedural solar system, and we get, we're done, a thing that, oh wow, why do they look all green?
They're all Earths.
Oh, they're all selected. That's why. So that was all their colliders and stuff. So we have kind of a solar system. It's a zany one because the moons are way too freaking far away from their planets. But yeah, it's looking better than it was. The planets are all circular orbits right now. They are all designed so that they're going to be further away from each other, but we have all these rogue moons going around, so we're going to tweak that, fix that, and make it look a little bit better, and then we'll start working on changing the way that the individual planets look so they're not just all blue. We'll probably just start with the color thing, and then we'll try and play around with some texture or maybe some shader stuff. So, this was our example solar system that we had here. I've just got it disabled. We could probably remove it from the scene at this point, but I'd like to keep it there. And I actually have the files on the description this time, so if you guys want to catch up on that. So, this one looks like it didn't generate as zany as the last one. Oh, much smaller solar system this time, I guess. Alright, so let's tweak some of these values real quick. So, right now we've got min moon size and max moon size, and then we've got min moon distance and max moon distance. And I want to double check in our script that we're not doing something silly. So if we go into our create solar system script and wait for MonoDevelop to figure out what's going on. Alright, so I just want to see what we're doing for the moon distance. So moon distance plus equals, okay, yeah, this should be fine. Alright, so right now let's look at, so our min planet size is 0.5 units and our max planet size is 50 units. That's quite a range. And so let's put the max moon distance at 1 planet size distance. Actually, let's just leave it really low. Let's go with like between 25 and 10 and see if that brings in our moons a little bit better. Do we get any moons this time? Oh, this one has moon. Alright, so I'm going to focus on this and see if we can find our moon. I'm not seeing it. So where's the moon? Alright, so there's a moon. It's freaking out. What is it doing? Where is it? Oh. Still seems awfully far away from the planets. Let's go really close on these and see if we have a problem. So we're going to force the moons to generate...
Is the distance being set before it's... Yeah, it is being set before it's parented, isn't it?
It should be, yeah. Yeah, the distance is being set before being parented.
But do we want it to be? Then it's multiplied when it's parented, isn't it?
I thought that when you parented something, it automatically tried to keep everything, like, does some magic at that point. We'll look at that in just a second, after we see what happens when we change these sizes down. So the min-moon distance, let's make this 1, and maximum distance, let's make it 2. So now we're going to go to one of our planets and see what we got for a moon. Alright, so pause. Let's see what's going on here. So how far away... So this is this parent planet, right? If we go to here, yeah, this is parent planet, and that's the moon. So this one is at 565. Oh yeah, because this is 500 units away from the planet for some reason. So you might be right. We might be getting hit by Unity here somehow, but I want to just double check that we've got the variables being set right here. Moon distance plus equals... Alright, so planets are transformed at local scale dot magnitude divided by 2.0f. Alright, what's the local scale of our planet? 32, 32, 32. So that should only be 32. All right, let's not take any chances here. Let's actually set it to 1 and 1. Then we can find out exactly what's going on. If we have a variable distance, then it's almost certainly what Jeffrey was mentioning. Do we have 2 of them with moons? Yay, we did. All right, so I'm just going to find the moon here again. If you double tap F, you'll focus on the object and it'll keep it moving around here. So we've got this one. I'm going to pause. Where's the Earth is? Okay, so that's its parent. And this is the moon. So it is, yeah, a whole lot of units away. And the other one here, is it a different amount of units? Moonits. Yes, it is. So we're getting different values here. That being said, the values might be based on the scale of the parent object. All right, let's do what Jeffrey suggested and see what we get. So what you're saying is instead of doing the transform first, well, you do the transform first.
Well, it does fix the... Actually, when you parent, it does change the transform so that it stays in its current position.
That's
so
what I thought.
I think it's not starting where we intend it to, maybe.
So let's see. Moon distance. What does moon distance actually do here? So we're going to do distance vector 3 forward times distance.
Oh, it's based off of the planet's local scale magnitude over 2.
Yeah, that should be fine, because that's the radius, basically. I just did it that way. And,
oh, wait.
yeah.
That's local scale, but it got parented to the sun.
Yeah, it's still... I don't think it's a problem still, because it's not like the here, let's look at this again.
But the moon isn't actually attached at that time, so we would want...
Yeah.
Wouldn't we want the global...
Maybe, but
glossy scale?
I'm going to look at this real quick. So the scale is still very small. It's nothing that would justify the just utterly ridiculous distance that we're getting here. Let me just make sure that I've set these things right and I'm not crazy here. Min moon distance, max moon distance. I just want to find out min moon distance. There's no fill moon distance? Alright. Alright, so yeah, it's just min moon distance, max moon distance. So transform dot position plus vector 3 dot forward times distance. So this is just adding to the z, which we see here. If we look at the moon here, you'll see that the z is the only thing that's being affected here. What else were you looking at?
The only thing we do for moon distance is the planet's radius and the random distance.
Yes.
So that would start it near the sun, right? We also need the planet's distance.
Oh, transform position. Thank you. So this is our problem here. Instead of transform position here, we want, because that's just this script, we want parent dot transform dot position. Very good find. This may fix it. Alright, so now let's see what we got when we do one of these. Yay! Look, it's a moon going around a planet. So I think we fixed it. That's awesome. Alright, so we've got... I'm going to do something to make our lives a little bit easier to see what's going on here. I'm going to create a... okay, what we're going to do is on each of these, we're going to component rendering... No, it's not rendering. Effects, there we go. Trail renderer. We're just going to throw these on there. I'm not even going to set them up, and this way we'll at least get some orbits here so that we can see what's actually going on. So it looks like, man, that's a lot of planets. Is that the, how many planets did we say we could have? Oh, 15. How many is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, we rolled a 15. But yeah, so now if we go over to one of our planets here, we should be able to see its little moons doing things. There they are, cruising through the universe.
Can you change the... I know you can on line renderers, but for trail renderers, can you make it local?
I think trail renderers are automatically local, but I'm not sure. Well, what did you want them to be doing?
Well, it looks like they're global because the trail is going back.
Oh, I see what you're
the
saying.
planet came from, as opposed to showing the circular path they're taking around the planet.
I see what you're saying. Yeah, I don't think I can do that.
It's not a big deal.
Yeah.
I mean, this is just to see it easier anyway.
Exactly. Is there a way I could do that? I'll have to think about that. I don't think there is an easy one right now. So it looks like we fixed our little moon problem. So we just had a bug in our code, not uncommon. One of the things I noticed here, when I was setting up these values, they're all positive values, and for the orbits, we should probably have it so things can actually, or do planets always go in the same direction? Well, I guess they don't have to, technically, but they usually do, don't they? Just the way things... Hold on. I'm going to ask a stupid question.
They don't always rotate the same direction, but I don't know if they're... Well, the orbits are...
I guess it doesn't technically have to be the case, especially if you had a rogue planet, but I guess if it forms up, it would make sense that they're all the same. Alright, I just want to see if there's any questions here or anything. Nope, doesn't look like it, although I don't trust YouTube. Gas giants, please. That was 11 minutes ago. Alright, that's new. Yeah, we'll see about making some gas giants. Right now, we've got some really big planets as it is. Like, if you see this, the minimum planet size is 0.5, and the max planet size is 50, which is gigantic. We're considering... I think our scale right now is 1 unit is about an Earth scale. Kind of. No, we're just making stuff up right now. But yeah. So, but yeah, we can probably make it so that they look different at the very least. So I'm happy to see that the orbits are actually doing the right things now. And what happened this time? There we go. So yeah, it looks like things are actually working. So that's cool. It's weird how these look at an extreme distance, the pixel culling and stuff. Line renders were not designed to be used at distances, at great distance, so. Let's just keep them all going in the same direction. If you wanted to make it so that they could do random direction, the easiest way would just be to, in the minimum planet distance and max planet distance, set it to, like, negative 500 to 500 would allow you to do that.
You could demonstrate that
Maybe.
pretty easily with
Wait, no, that wouldn't
right
work.
now.
That wouldn't work, actually.
Try it for moons and make the,
For the rotation,
number of
sorry.
moons like 3 to 5 or something.
All right.
So it'll be likely that you'll find moons going different directions.
3 to 5, and let's make the moon. So let's make it so the moon's going to be randomized. So let's do negative 30 and negative 30 here. And now we should actually see that we have... Whoa. Something's cruising. Or I've done something terribly wrong. Those ones are all going the same direction. Alright, let's look at...
They're going different directions. Oh, wait. No,
No,
they're not.
those are all the same direction again. Wait, but why... Oh, I see. Sorry, that's the same planet. Of course, they're all going in the same direction.
They're going the same direction.
Yep. There we go.
Yeah, we have a winner.
So yeah, so that's if you want to randomize the direction on things, all you have to do is make sure that there's negative values in there. You don't want to put negative values on the distances though, because that will mess up our algorithm pretty good. Because it makes a lot of assumptions that that's positive. Mm-hmm. All right, I'm going to go ahead and
Undo those changes.
what, the ones to these? Yeah,
The
let's
negative distances.
Oh no,
Negative-
let's
negative
let's keep it.
rotations.
Actually, I kind of like it. So let's look at actually making the planets look a little bit different in a random way, because right now they're all looking like Earth. And I'm going to actually rename Earth here to be planet, so that we don't confuse things. And I'm going to call this star. So that doesn't make much of a difference. I'm just doing it because that's more of what we're doing here. So planet is just, it just happens to be blue here. We're going to actually change some things around on it. And we're just going to start with color because that's really simple. And so I'm going to create a new C# script. Going to call it...
Move it from prefabs.
Yeah. Or should we put it in our create solar system script? Let's take a look real quick. Let's put it in this script just because... And this thing's doing that thing again. let's just put it in here because it's got all the other data in here for everything. So we might make a helper script or something if it's appropriate, but it may not be. So let's see here. I don't think we're going to need...
If we put it on the planet prefab, then we could make multiple planet prefabs and spawn them at random in this script.
This is true. This is true. I'm gonna work with this script first, and then we'll see about what we need to put on other things. So I'm just gonna do a random color first. We're just gonna do a very, very basic random color. So instead of celestial body, instead of celestial body, we'll just totally randomize the colors for right now. So all we're gonna do is planet instance. I really shouldn't call it that because this could be anything, but let's just call it so we're creating the instance, we're setting the size, we're setting the period, we're creating the planet strut for it, setting everything for that, and setting the parent. So somewhere in here we want to change the way it looks. So let's go ahead and do it at the end. So what we're going to do is planet instance dot renderer dot color, no, material dot color, and we will just for right now do a random. Is there a random color?
I think there's color dot random.
There is?
Or no, maybe not. I don't know.
Nope, there's not. So we will make our own
Color
randomizer.
30, what's color 32 have? I think
Color
that's faster
32
than color
dot.
anyway.
It's got a whole lot of nothing.
It has lerp. That's
It does have
useful.
lerp. That is super useful. All right, so what we're going to do here is, for right now, we're just going to do a random color, which we'll do by creating a new color. What's the difference between color and color 32?
I don't remember. I think 32 is...
Oh, it's actually the
resource
byte
intensive?
stuff. I'm going to just use a regular color for right now, because we're only doing this generation once, and it's not going to cost us really anything. New color, and I think we can actually specify the RGBA values in the constructor here. So
if you're doing a lot of,
random
if you're like
dot.
doing pixel data over an entire texture or something, you probably want to use color 32.
Yes,
but,
yes, absolutely. And if you're doing it every frame or something, yeah.
I think I did that at Play Habit and started out with color and then read about color 32, and it cut the time of the program down to like 10% of what it was before.
Nice. That's awesome. All right, so so this takes a floating point value between 0 and 1, which is actually really convenient because random.value gives you a floating point value between 0 and 1. And so we can just do that 3 times here. And we don't need to specify an alpha, and it'll probably just assume 1 for that. Although if we wanted to specify an alpha, we would specify 1. So save scene, save project, just in case. Hit play, and theoretically we should have randomized colors on our planets here. It looks like we do. I'm surprised the star didn't get randomized. Do I generate that separately? Yeah, we do. That's before everything else. Okay. So our sun doesn't get changed, but our moons and our planets should have randomized colors. So if we go to our planet strut, what are we doing? No, just planet. Any of them. I don't care. So we got this one. This nice. When I deselected it, of course, stops following it.
Just pause it.
Let's just pause it and look at them. Yeah. So we've got this one here, which is this nice maroon color. We got like a few of them that are in that color range. Do you have any greens here? There's a nice deep blue over here. And do the moons have random colors? Let's see if that actually happened.
They should, because they use that same function.
That ironically it was a very uncolored sphere.
The moon has a huge
Yeah.
trail.
Yeah, the trails are bigger than the moons themselves.
That's no moon.
You know, I kind of like the trails, so I'm thinking maybe we should make the trails a little bit nicer. Like actually make them sized to whatever they're attached to and actually colored based on what their color is. This is a very dark moon here. It's entirely made out of volcanic ash or something. I don't know.
You are looking from the back side of this where the sun is facing.
Oh, okay. Yeah. Still pretty dark, but... Alright, so that's really, really, really basic, obviously. Do I want to do the trail thingy? I kind of want to do it for the planets, at least. I'm going to get rid of the trails on the moons, because it's just messing with me. So we're going to get rid of the trail renderer on the moons. And I want to just really quickly make it so the trail renderer actually kind of follows some of the rules of everything else. So, how do trail renderer set up? I guess I can just do trail renderer dot trail equals planet instance dot get component trail renderer, and then we check to see if it's null because we have some things that don't have trail renderers at this point. So if trail does not equal null, then we can do things to it. And what we're going to do is trail dot color, no, dot material dot color. Okay, so since we're going to actually need it to match, we're going to want to do this separately here. So what I'm going to do is up here, planet, actually let's call it, yeah, whatever, planet color.
Base color.
Yeah. So now we can use planet color, and it will be the same color in every instance that we use planet color because we have assigned to it once. And we can set the same thing here, otherwise it won't match. And then trail dot render, actually it's trail dot start width. Is there a start width and an end width? Yep, start width and end width. Start width, let's call it, so have we already parented the planet? We have. Okay, so what we'll use is start width equals planet instance dot transform dot lossy scale, and trail dot end width, let's actually just make that 0.0f.
Lossy scale is a vector. Is start width is a float.
Oh, is it? You are absolutely right. So what we're going to do is lossy scale dot magnitude. We may have to divide by 2, but let's see what this does first too. Oh, planet color does not exist in the current context. That's because we didn't declare it. So color, planet color is equal to a new color. Yay, that fixed our problems. Alright, so let's see what we got here. So it looks like the coloring's working.
I think
it looks like it's double sized. Like yep. Yeah. One of those is just cruising. That guy's got a huge speed. All right, so let's have that real quick. So where is that? There it is. Magnitude divided by 2.0f. Yay, that looks clean. Kind of fun.
And we can see that planets are going different directions too.
Yes. Wait, why are the planets going different directions?
Because you left the...
Did I change the planets?
You left the rotation, or...
Oh, I did. Wait. we didn't change the moon one, did we? Oh, wait, I see. We don't use... Okay, well, we found another bug. Because if the moons indeed were rotating differently... Alright, I gotta find out now. So, moon rotation, moon orbit period. Yeah, we must have been kidding ourselves when we thought that they were rotating in other directions. Because it's the planets that we messed up. Alright, let's do 10 here again, 10 here again, and then actually do it on the moons. -10 and -10. Oops. Oh, we got a real small solar system this time. At least they do have moons, though. Lots of moons, actually. So there we go. Those are definitely moving in different directions,
yes.
And all the planets are definitely moving in the same direction. Cool. I like this. Alright, so we have a random solar system. It's generating planets. They're different colors. They're different positions. They have different numbers of moons. They have different orbits and stuff. We have color. I think I already said that. Let's actually try and make it look like these things have... let's actually make these look a little bit more like planets and actually make the color and texturing look a little bit more randomized. So...
Let's check the comments real quick.
Sure thing. Good idea. Thank you. I'm going to hit refresh because I think this thing's lying to me. Oh, I'm just going to assume this is not spam. This has been messaged as spam. Alright, well I clicked not spam, but I don't think it's doing anything. Array of colors and planet random color at instance. We can totally do that. Though we just did random on that one. I don't know what's going on here. You guys see what we have to work with here on YouTube. So yeah, so looks like there's no overbearing questions in there, or even underbearing questions, so let's just actually play around real quick with texturing. So what I think I'm going to do is, let's play around with, let's start with a texture and see what we can do with it. So I'm going to create a very basic texture in NeoTexture Edit. This is a free app, you should download it. It's... I can't say this is the best app I've ever worked with, but for creating and repeating texture is pretty well suited. So I'm going to do pattern Perlin noise. We've worked with Perlin noise before. This is an implementation of it here. We're going to change the persistence of it to make it a little bit blurrier. Something like that. That'll work. And let's get a little bit more texture. There we go. So I'm just going to export that. So this program, when you generate Berlin noise, it's automatically set to periodic. If you disable that, it won't actually repeat properly. If that's enabled, though, it will actually repeat on the seams in every direction. So we're going to do... we don't need it really that big. I'm just going to do 256 by 256. We're going to call this what do we want to call this? I'm going to call it planet texture. And where did I actually say that? There we go. So we're going to put this into textures. And what do we do for these other ones? Automatic true color. Yeah, why not? And we're going to put this onto our planets. that actually work? Mesh renderer materials. Okay, it looks like it did. Why is it that it doesn't show the... Call me crazy. Didn't it used to show, like, the texture stuff here?
Did you make a material, or did you just put a texture on there?
It made a material for me when I put a texture on there. Made this material right here. I'm just trying to figure out why it's not... Because doesn't it normally show... Okay.
Maybe the trail renderer.
Maybe that messes it up. Let's find out. It does. Okay. Interesting.
Can you add the trail renderer and keep it? Or... Because the trail renderer uses materials. So.
What I will do... That's really strange. But what I'm going to do to fix that... So evidently trail renderer doesn't make things happy. So the moon, you can see that it has this little thing here, but the planet, for some reason, you can't see its main material. So what I'm going to do is I'm actually going to copy the component on... Actually, we'll bring out the planet here. We will create an empty game object, put it inside the planet. We will set it to 0, 0, 0. And we will put our trail renderer inside of that. Paste component as new.
And call it trail.
And yes, and we will remove it from here so that we don't have that problem anymore. There's our texture, it just appeared magically. And trail. And so then we're going to apply. And now our planets have trails, and it won't be messing with us anymore. And the moons didn't have trails, and the sun didn't have trails, because that doesn't make any sense anyway. Well, I mean, it makes sense, but we don't generally worry about the sun. We're worried about this. We're very solar-centric right now. All right, and so now we have a problem where we're not actually changing the color of the trail renderer, and that's because we're not getting the trail renderer. What's happening here is it's going to do trail renderer trail equals planet instance.get component trail renderer, and it's going to return null because there isn't one on the object itself. This is very easily fixed by using a different version of getComponent.get component in children. This will return the first component that it finds with that in any of the hierarchy underneath the current object. So if we hit play, that should fix our... There we go. Our sizing and our coloring is now based on the planets again. That's cool. And I'm actually going to change the trail material slightly. So right now it's not using a material, which I guess means it just generates one at some point. Can we edit the script for trail renderers? No, we can't. They're magic. Okay. So what I'm going to do real quick is I'm going to create a new material. We're going to go into materials here, create material, and oh, I already had a new material. All right, let's use that one. We're going to call this trail material. And the reason I'm doing this is because I want to make it so that these are full bright. So we can just set these to, let's go with
vertex lit.
Yeah, self-illuminated vertex lit. So now if we hit play, we won't get the shading on the trails anymore. They'll just be, well, no, we're still getting shading on the trails. Why is that?
Did you put the material on the trails?
Maybe I didn't. Probably didn't. So let's look. We're going to go to our prefabs. Yeah, I don't think I did that at all. Yep, I didn't. Good call. So we will now take our material and we will drag our trail material onto element 0 here. Oh, now it shows up. Okay, whatever. So we hit play. And now these things should, yeah. So these now will always maintain their color so that the shading doesn't change. It actually kind of look cooler with the shading. Maybe I'll switch it back at some point, but I just wanted to show you how to do that just in case.
Well, with vertex lit, we can change the shininess and stuff.
This is
That
true.
might-
Like make it shiny or something. To make it cool looking again, or to make it what? So changing the shader right now won't actually affect these things, just because even though we're affecting the prefab, these things have already been instantiated. But I want to actually look at this real quick. So if we did like extra shiny, hard to tell that it's even doing anything. Let's make it red, then we'll be able to tell, right? Yeah, I don't know. I'm not going to save those changes. So let me just save real quick. So we've got 15 minutes left. Let's look at actually getting these textures doing something interesting. So
We could leave them diffuse, but use separate lights for them, although I don't know if you want to use a light layer just for the trails.
yeah, probably not. Alright, let's look at some things. So first let's see if there's anything that...
Oh, it's
this,
material. We could just create our own gradient texture.
Yes. Yeah, we could.
Did you say that?
No, I didn't. I didn't mean to give you a look that made it look like I said that either. But I evidently did. So... Alright, so... Planet texture. So, do we have textures on the planet right now? Did I actually put this on there? I did. So let's actually look at our planets real quick, just see how they look with this texture map. I'm just going to get in real close on one of these guys. Alright, so, yep, you can see that we have our texture. And actually you can see that there's the specular, now that we're really close to these things. So, what do we got going on here? So I'm going to turn off the... What am I going to turn off all these things? No, it's not just the collider. It's definitely the... I don't think there's a way to turn off the selection effect, is there? It's weird. I was just going to try and get rid of the grids on here, but I'm not going to bother with it because it doesn't look like it's going to work. So, so this gives us a little bit of a look, but all of the textures are exactly the same. I don't know where I'm going to run with this, but we'll figure something out. So they all kind of have a little bit of a samey look right now. We could generate our own textures using Perlin noise at runtime, which would make them less samey. The other thing that we could do is, right now our planets are just, they're all this uniform color, which honestly you rarely see that on planets. It's generally you'll see like bands and you'll see different colors, and if the planet is like a inhabited planet like ours, you'll see a really big range of colors and stuff, because you'll have oceans and you'll have flora and fauna affecting the look of things. So let's see what we can do to simulate some of that stuff. What I was thinking about doing was doing a color table lookup thing, but that requires a shader. I'm not sure if I'm prepared for that. Let me see if I've got one that I've been working on in the past. Sun Fun. Here we go. That looks promising. So I think inside here we've got some shaders that I played around. Palletized color, there we go. So I'm going to steal this into our project. Now I have to find a way to get this to people. Let me put it in the description real quick. Let's see if it works first, though, before I go crazy here. So what this is this is a version of this shader is this? Okay, so what this shader does is, or what it should do, is it uses the second texture as a lookup for what color to put in the main texture based on value. And so what this means is, since we have this black and white texture that we can use, we can now have a colored texture that will replace each shade of black to white with whatever color's in there. So, as an example, what's a good thing that I can do for an example? Let's create a lookup texture for this. I'm going to create a new folder called shaders real quick. I'm going to make sure this thing works. So, I'm going to open up Pixelmator. Actually, I can do this in, let's do it in NeoTexture because that's free, and everyone can have that one. So we're just going to create a pattern gradient here. I forget if I'm using the, which component I'm using. I think I'm using left to right on it. Or I might be doing upper left to lower right, which means it'll work in either case. So I'm just going to make one, who cares. So let's just save this out right here. Actually, no, let's make some colors so that we'll actually be able to tell what's going on. So let's make an Earth-like planet, shall we? So the highest one should be white, that's fine. Lowest values are going to be deep blues. We're going to have some, I don't know, some beaches. I'm just making this really basic here. And some mountains, which will be nice dark. Let's actually use one of these things. So we want some sort of brownish here. And where did that one come from? Let's get rid of that one. And we want very little on the ice. Let's start with that. Now, is it possible for me to actually make this one-way linear? No, it looks like it goes two ways regardless. That's annoying.
Oh, like a sawtooth?
Yeah.
Well, I was GIMP.
Yeah. I probably should install GIMP just so that there's a free thing. I usually use Pixelmator when I'm doing the programming for the other stuff. People who are serious about this stuff are probably using Photoshop, but let me see if there's a way I can do like pattern function or something. It'll just let me do this. So if we do combine or add, no. Min, no. Actually, I know what I can do. Maybe. Can I just offset this some way? No, because it's still duplicating no matter what I do there. So let's put this back to 0. Did that actually? I guess it's working. The interface on this program is not the greatest. Alright, fine. Wait, maybe I can change the scale in some way. There we go. That'll work. And let's go ahead and rotate it. No, let's see if this will just work. So we have blue to oranges to white, and actually we should probably have more blue. We should probably like make another one here just to force. No, that's not what I want. Let's make another blue. If you double click somewhere, it gives you another one that's similar in color, so we can make that like that. Alright, let's see what this actually looks like. So I'm gonna export image. We'll do 256 by 256, and we will do planet color map. I'm gonna call it lookup. Lookup tables are really common in shaders once you get some slightly more advanced shaders, and so that's what we're basically creating here in a text, in the form of a texture. So I'm going to make sure this true color doesn't really matter. And we're going to now go into our planets. Planet. That's in our prefabs. There we go. So our planet is going to now use... What did I call this thing? Pushy pixels. I guess it's under pushy pixels. All right. Palletized color. So we have our main texture, and then we have our lookup texture. And you can already see in the preview that it's done something interesting. So if we hit play now, and we go into... The fact that we're coloring these may actually cause some problems, but we'll see. Actually, I don't even have a color component here, so we're not coloring them at all anymore. So we've lost the color information, but let's see what this actually looks like on the planets. They're going to all look really similar again. So let's just hit pause on this. So there's our planet. We've got a couple of oceans. We don't really have any. You can't really see the ice peaks here, probably because we didn't have high enough values in the black and white texture map. But you can see how this is now basically kind of added some variety to the way our planet actually looks. So what I'm gonna do real quick is I'll actually get this shader to you guys real quick, just in case you're watching live. So I'm going to open up Dropbox. I'll call this palletized color. Might as well just get all of these things. Let's just compress 3 items. We're going to call this CWU supplemental 140505. Copy public link, and we will paste this into our description somehow. Oh, internal server error, thank you. Oh, come on. Right now, really? Is this what we're doing? Is everyone getting this problem? Highly trained monkeys have been dispatched according to that. So let's see if maybe I can do it from here. Nope. Nope. No. Can't do it. Alright. Sorry folks. Maybe I can do... Here, let's see if I can just do a comment real quick. I don't want it to start playing, because that'd be horrible. Comments can't contain links. Alright, whatever. I'm done. I'm over it. Alright, so what we're going to do, though, is I'm going to modify this slightly. I want to actually have it so that it can take a color as well. So what we can do there is... so we're going to need a property. I'm going to call it color, because that's what it's actually called internally on Unity. We're going to call this the tint color... I may have to look up how to actually do this. Let's see. Unity shader examples. Main text, bump map, detail. They had some colors? Ones that actually, oh, there we go, rim color, there we go. So it's a color, all right. So tint color, color equals, all right, so you can just set a default color. I'm just going to create. So I haven't learned all of the terminology on this stuff myself. So this will just default it to white. I probably could use white like below there, but I'm not 100% sure, considering that's a macro for a texture in that case. So there's our color, and then we're going to need our actual color used here. So uniform float for color, and then finally, we return text 2D times color. Whoops, underscore color. Let's see if that will compile. If it doesn't, we will get a very unhelpful message. But it did. I want to mention how unhelpful the compiling is on this. I'm going to do this because this is an error. Yeah. Share error. Share program has errors on line 17. Oh, it actually... Oh, it got further than last time. It used to just give me this error. I'm very happy. Unity has improved its errors on here. Before it was like, error on line 17 is like, what's line 17? That's not where the error is. That's nowhere near it. And like if you have an error anywhere in there, it had that problem. But I guess they made it a little bit better. So that's cool. So if we save this, now if we go to one of our planets, I think this is based on the prefab, yeah. We have a tint color here as well. So theoretically, we should actually get our color information back now. I'm not sure how it's going to look, but let's see how it actually looks. So because it's tinting, it might actually defeat all of our point anyway, but I'm curious to see what it will actually look like. No, it didn't defeat it completely. So, but it is actually tinting it, and so cool. So now we're getting some color variety back again, and wow, that moon is just cruising. All right. So, I think that's probably a good stopping point for right now. We'll work with actually making the textures a little bit more actually randomized next time as opposed to based on an existing texture, and we can also change the lookup table to be the same deal too. So I'm going to save project, save scene, and we're going to go over, I'm going to just double check to see if anyone had any questions real quick. Don't play. Don't do it.
Did it say live 4 minutes?
I hope it didn't. Am I going to Unite 2014? It's in Seattle. I might. I don't know. Alright. Looks like everything's good. So, I'm going to open up Perforce because I almost forgot about that. And we will check in our changes. So while that's loading real quick, I just wanted to quit Unity here explicitly. That way I know that it's done writing whatever files it's writing. And I am going to right-click planets, choose Reconcile Offline Work. And we're going to get all our files here. And we're going to... Okay, so what do we get changes here? So, change create solar system, that's true. Shaders, we added a shaders folder. We deleted this material. Evidently we had that checked in. Makes me a little worried. Well, we probably weren't using it for anything important. Yeah, so looking good. Looking real good. Submit. Planets have trails and now look different. Also fixed moon positions. Yep, YouTube is not having a good day today, it seems like. So, anyway, what are we doing? No. Thank you for joining us tonight. I had a good time. I think that we did some good progress on the solar system today. If you have any questions, please feel free to email me at pushypixels@pushypixels.com. God, there was too many ats there. And you can also tweet me at Drakfire. That's DRAKFYRE. And you should still buy Phil's game, Robot Alone, but that's all I'm going to say because he's not here. And
and beat his high score.
Oh yeah, beat his high score. Did you have any? Well, actually, you wanted to show something. We're going to do a quick preview after the end of this for something that he has for next episode. He being Jeffrey. Oh yeah, I finally did actually do it. So this is just one of the boxes. I got new coasters done and new keychains done. So we have coasters, and these will be going out probably Wednesday. I'm going to be packing them out for shipping tomorrow night, and then on Wednesday I will be shipping them out. At least that's what I have time for. So thank you for joining us tonight, and you guys, or did you want to show it before the bump?
I don't care.
You don't care? All right.
We don't even have to show it.
I'll show it after the thing. Thank you for joining us tonight, and you guys have a great night.